continue from where we stopped in our previous class. You remember that the last class we had together, the topic we actually stopped with was bearing and distance. And I would like to take a recap very fast on one or two things we said before we look into our next example. While we started bearing and distance, I call your attention to the fact that there are two major types of bearing, which are the 3-digit bearing and the compass bearing. Obviously, for 3-digit bearing, I gave examples like 082, 137, 219, 316 degrees. All these numbers should be in degrees. And for compass bearing, basically, you will know that they are two different things. So you don't have to just mix it together. If this is 3-digit bearing, you have 0, 3, 6, for example. You can see that the numbers there, they are 3 digits. But if you have compass bearing, you have a 72, the north of east. 72 degrees, the north of east. This is one of the basic way of writing compass bearing. We'll be focusing on how do we interpret question on compass bearing and how do we draw the diagram on compass bearing. But before I take the example, let's take this as a case study. If you want to place, of course, you also need a cardinal point. Where this is my north, my south, my west, and my east. 72 degrees is between the north and the east. So your location is within the quadrant of the north and what? East. And the value of the location is 72 degrees. Now, how do you place it? If you are placing 72 degrees, we are looking at the two different diagrams now, the possibilities of what you can have. It's either a student will say it's placing, knowing fully well that it's between north and east. Let's say this is position P. Another student, knowing fully well it's between the north and the east. That's student B, student A, and student C. We have three different diagrams. Now, we are trying to establish how to place diagram of bearing values under compass bearing. This is 72 degrees north of east. This is the first diagram from student A. This is the second diagram from student B. And this is the third diagram from student C. If I may be asking this question from my audience, which one do you think is correct? Maybe I can take a general sampling now. Which one do you think it is correct? A. Okay? If we are saying A, we are saying it is possible that a student B can draw this diagram this way. Why is this one wrong? From my end, why B is wrong? It's even between north and the east. It's also positioned between north and east here. Fine. But we are saying it is wrong. Remember I said in our previous class that when you are drawing diagram in bearing, you should always assume you are drawing to we should always assume you are drawing to okay? Looking at this, you are measuring from the north, clockwise direction. This is 72. The remaining angle here should be what? 18, okay? You are measuring from the north. This is clockwise direction, this is 17. The remaining angle here should be what? Can 18 angle be bigger than 72? So, this does not show that this student has actually put drawing with the assumption of drawing to scale into consideration. So, this will create problem for this student. Moving here, it is also located between north and east. But what are we saying? We are saying that this person did not even start his measurement from the north. Another wrong thing here is the position of this angle for compass bearing should be between the north and the location, or the south and the location, not either east and the location or west and the location. Am I communicating, class? Yes, great. So, with that understanding, we can quickly look at our first example, considering a question that involves compass bearing. All right, I'll be dictating from my end. Please, students, let's write now. All right. A ship leaves port P and sails on a bearing of 45 degrees north of east. A ship leaves port P and sails on a bearing of 45 degrees north of east to a port Q, full stop. Sorry, to a port Q, comma, 15 kilometers away. To a port Q, comma, 15 kilometers away, full stop. It then says on a bearing of 45 degrees south of east. 45 degrees south of east. To port R, comma, 20 kilometers away. 20 kilometers away. 1. Represent the information in a diagram. That's the first question your examiner is asking you. He's saying represent this information in a diagram. B. Calculate correct to the nearest whole number. Calculate correct to the nearest whole number. 1. Distance from P to R. Calculate correct to the nearest whole number. 1. The distance from P to R. 2. The bearing of P. The bearing of P from R. The bearing of P from R. Are we together? Yes, okay. The first thing you do when you have a bearing question is that you draw the diagram and you draw it correctly. They are even saying from the examiner end now that you should do what? You should represent the information in a what? In a diagram. All right. Let's quickly look at how to translate that information into diagram. taking it from my end, I have a ship that leaves port P and sails on a bearing of 45 degrees north of east. Is that correct? Yes, a ship sails from what? Port what? P. All right. That means our starting point is what? P. And obviously, you start with your 4 cardinal points. And the bearing is what? 45 degree north of east. What is the other name? How do we, if the examiner is not using 45 degree north of east, what else can be said? And it will be the same exact thing they are saying. That's one, very good in terms of 3 digits. Or another thing, there is another way they can present 45 degrees north of east. Northeast, that's a good one. Appreciate that guy for me. That's a good one. Students, let's note that carefully. And what am I emphasizing at that point? Northeast is the same thing as 45 degrees north of east. It's the same thing as 045. Am I communicating? Yes, sir. Great. So 45 degrees means you're coming out here from the middle, exactly from the middle. And your 45 should be from the north in the clockwise direction to the position what? Q, okay? So you are moving from, somebody should read from the audience, please, so that we can manage our time. Okay, a ship leaves. Okay, it says on a bearing of 45 degrees northeast. Okay? 15 kilometers away. Hold it. 15 kilometers away. This is 15 kilometers. This is Q. All right. It then says on a bearing of what? 45 degrees southeast. This is south, this is east. And it is 45 degrees south of east. Okay? It's the same thing as southeast, right? And what is the distance? 20 kilometers. All right. Coming out from the southeast, 20 should be longer than 15, yes or no? Yes, sir. 45 should be here and not the other side. Okay? You will, this is to where? R. So this is point R. Joining the 2 points together, you have your right hand, you have your triangle, and obviously this place is what? Because the angle here is alternate to the angle here, that means that angle will be equal. The total angle here will be 90. The distance between Q and R was given to us as 20 kilometers. All right. This is the first challenge your examiner is asking you to deal with, that you should illustrate the information in a what? Diagram. In a what? Diagram. Thank you. With that, we can now look at what are they asking us to use this diagram to do. The first one says, calculate correct to the nearest whole number. The distance of P to what? R. If I may ask, what type of angle is 90? What type of angle is 90? I don't want a chorus answer. Yes. What type of angle is 90? You said is an included angle. Okay? If it is an included angle, can somebody tell us why? Can somebody tell us why? Why is 90 an included angle? Oh, I can see a hand over there. Two thank you. Two known sides of a triangle. Can we appreciate that guy for me? But I can also say that that 90 is telling us that that triangle is a right angle. Yes or no? Yes. So you can address this diagram as a right angle triangle because one of the angles of the triangle is equal to 90. You can also address it as a triangle that you want to use, see that 90 as an included angle. And the two should give us the same answer. Okay, which one are we picking? Are we just taking it as a right angle? Let's take it as a right angle triangle. Are we still together, class? Yes, sir. If you are taking it as a right angle triangle, then what is the application that should cross our mind? Pythagoras theorem or trig ratio. Those are the two applications that can go along with right angle triangles. Am I communicating? Yes, the two applications that should cross your mind when you are dealing with any right angle triangle is either Pythagoras theorem or trigonometry. For Pythagoras theorem, the condition around it is that you must be given at least two sides before you can find the third unknown side. For trigonometric ratio, you must be given one angle and one side to find any unknown side. All these we have said before, and I want to believe they are in your notes. And please, let's go over them. Even there's a second condition for trigonometric ratio. Oh, sorry, yes, for trigonometric ratio in a right angle triangle. You want to use trigonometric ratio, you can also use trigonometric ratio to find any unknown angle when two sides are given. For any two sides given, you can find any unknown angle. Are we still communicating? Yes, sir. Great. Quickly, if I say this place is y, that is my PR. Let's PR be equal to y. It implies that y squared must be equal to 15 squared plus 20 squared using Pythagoras theorem. Because y, the length PR, is our hypotenuse. All right. 15 squared is what? 20 squared is what? This is 625, right? And we are still saying it is y squared. Y, obviously, it implies that y is the square root of 625, and that is 25 kilometers. So this place is 25. Are we still together? Yes, the bearing of P from where? From R. Okay. I want to believe my student can see what I'm trying to do here. Because it is from R. Well, in our previous class, I said that we want to find the bearing of A from B. I made one analogy that I can also translate it and say, okay, can somebody, a student, help me get a bottle of Coke from the fridge? Is that not what we said? Yes, sir. Okay, and I said with that, it is an indication that to get that bottle of Coke, you must locate the fridge because you want to get the bottle of Coke from the fridge. Now, the bearing of P from where? R. So where are we going first? R. You want to get the bottle of Coke from the fridge. Where will you go first? Fridge. Come on. Fridge. Okay? If and when you need a bottle of Coke from the fridge, your senses is saying, go to the fridge. You need the bearing of P from R. Your senses must say, go to R. Okay? The next step is draw 4 cardinal points as where? at R. Then move in the clockwise direction. When you locate the north, move in the clockwise direction until you get to the line, joining the 2 points of consideration together. That is our bearing. That is our bearing. Am I communicating?
Yes, sir.
So the question that will cross your mind now is, with this analysis, how do I get that movement? I can see that I have moved 90 to this point, 180, 270. So already my bearing, bearing of P from R could be equal to 270. I can see plus something, plus the remaining part, which is, let me call it theta. So plus theta. That is my bearing. When you make this type of statement, your examiner also knows that you actually understand what you are saying or what you are doing. Great. How do I now get this theta? I can see that this theta is alternate to this place. Shebi? Okay, you can also decide. Okay, it's either you use this end or this end, depending on what is comfortable for you. But I will be using this end now. What will I do? I'll find the total angle here, alpha. I know that part of alpha here, the remaining angle here is what? 45. So I can also say alpha is equal to 45 plus theta, right? This implies that theta eventually will be alpha minus 45. So to get my theta, all my challenge is that I will just get the angle what? Alpha, and my theta will be known. Great. Can we get alpha? What do we use now? I set a trap for you. You are entering into it. A good one. You can't be smarter than your brain. And now I'm smarter than you. Because that question, I've answered it first by saying that SOHCAHTOA, which is trigonometry ratio, is also what you can use for what? For right angle triangles. So the first thing I expected from my audience is that to get any angle, I gave you conditions for to get angles this morning. And I said to get any angle, you must just have at least one angle and one given side. Okay, now I have this angle. But I also said, if you want to get any unknown angle, if you have been given 2 known sides, you can get any unknown angle. I have 3 known sides, safe. So I can get that unknown angle using my SOHCAHTOA. You can use sine rule, greatly interesting. You can use sine rule. But both will land you at the same answer if you use them correctly. All right, for me, I want to use trigonometry ratio. The opposite to this angle over the hypotenuse. The opposite to this angle over the adjacent is what? Is how to find my alpha. Now, if it is opposite over hypotenuse, that will be what? That will be what? So sine alpha will be opposite, which is 20, over hypotenuse, 25. What is this one? 0.8. It implies that my alpha will be arcsine 0.8. What is that? 53.1. 130. So 13 degrees, okay? That is alpha. Can we now get theta? I can use this place. I hope you know that I'm moving from there to here, right? Yes, sir. So my theta should now be alpha minus 45, and that is what? 53.13 minus 45. That will be what? 8.13 degrees. What is now my bearing? The bearing will now be 270 plus what? 8.13 degrees. 270 degrees. What is this? 278.13 degrees. This is, that's 278. 278 degrees to the nearest whole number. You have done well. And I think I like your concentration. Can you appreciate yourself? Great one. Great one. Now, but I want somebody to tell me why this answer will be wrong. Why, okay, don't let me say why the answer is wrong. Why this answer should not be my final, my final answer. For me to have full marks now, why this answer should not be my final answer. Okay, somebody is talking here. The question was given in compass bearing. The answer, your final answer must come out as compass bearing. Appreciate that guy for me, please. That's very important. And these are the things we have emphasized over and over and over again in the past. So, you must just go back. Hello? You must go back and check. How do I convert this answer to compass bearing? And I want to do that simple analysis here very fast so that my student can see clearly. That should go off. I will be repeating that position of R here. You know, when we moved from the north, class, are we together? Yes, sir. You are moving from the north. This is my arrow. We are moving from the north in the clockwise direction until you get to the line. Joining, this is the line. That is this line. Are you with me? Yes, sir. Okay? This is the location of that bearing. The bearing of P from R. That is the location. Right? With that, all you needed to do is to work on this angle. I know this angle, what's theta? Theta is what now? 8.13 degrees. But where do we place compass bearing? Is it towards west or towards east? In your location, wherever quadrants you are putting your compass bearing, should your angle be towards west or towards the east? Yes or no? No. Your angle should always be towards the north or towards the south. So this is the angle you are looking for, beta. So I can say in this quadrant now that theta plus beta is equal to 90 degrees. Each quadrant is 90 degrees, yes or no? Yes, but theta is already 8.13, right? This is beta. Plus beta is 90 degrees. Beta, obviously, will be 90 minus 8.13. And what is that? 81.87 degrees. It will now be the north of what? The north of what? The north of west. The north of west. Right? Okay? But they said giving your answer in the nearest whole number. So this will be 82 degrees north of west. That should be our final answer. You understand what we are saying, class? Yes, sir. That's a good one. Please, if you have not finished writing, we can write now quickly because I'll be changing direction to another topic entirely.